So our lesson is mechanical oscillation. We'll talk about these topics. First, we'll do an introduction to do a revision about the types of motion, and which are the translation, rotation, and random. Now, our aim is to talk about the oscillation here, oscillatory motion. Then we'll talk what is the definition of the oscillatory motion, and then the types. In the part types, we'll talk about free, which will be divided also into undamped and damped oscillation, free oscillation. And then we'll talk about the driven and the forced. Now, with respect to the force, it's not مش مطلوب for the life science. Now, we continue. For the free undamped, we'll talk about, so here we'll deal with all these steps. What are the characteristics of free undamped oscillatory motion? What is the general study? How to derive the differential equation of motion using two methods, conservation of mechanical energy and Newton's second law. What is the solution of this differential equation, and how to determine some characteristics in this solution. We'll see that the solution will be in the form x equals to xm sine omega 0 t plus phi. So here we'll talk about the characteristics xm, omega 0 and phi, and then we'll talk about the graphs of energy, which will be the mechanical energy, the gravitational potential energy, and the elastic potential energy. Our study will be for a horizontal elastic pendulum, but we'll do at the end like a revision or like a remark about the vertical pendulum, and also about if you have two horizontal spring. So these will be remarks at the end. Then we'll talk about the damped and driven oscillation. So here we said we have the damped oscillation. So we'll talk about the damped, and at the end about the driven oscillation and how to drive the oscillation.